We'll try one more time to lay out this building. We're going to refine one that I started already and establish means of egress that makes sense, right? Let's talk a little bit about scale. There's architectural scales, engineering scales. We have a grid here, and every inch in this drawing is going to represent 40 feet. So I'm just going to write that down. Scale, 1 inch equals 40 feet. How do I know that? Well, if I use the engineering scale, you multiply the numbers here by the 10. So every inch here represents 40 feet. So from here to here, I have 300 feet, or if I measure it in inches, it's 7.5, right? So if I multiply 7.5 times 40 feet, I get 300 feet. So let's talk about what I've selected. There's my property line. And that's what we all started with. The site that's 300 feet by 200 feet in depth. These are those dimensions. 300 feet that way. I'm designing a building that's 100, whose footprint, not necessarily the shape of the building, right? Footprint, the part that it occupies is 100 feet by 200 feet. That means that I have a rear setback of that's 1 inch, right? These are 1 inch squares. The rear setback is 40 feet, and the front setback is 60 feet. So it's 60 feet, 40 feet. Front yard, 60 feet. Rear, 40 feet. And the side yards are, right, we're using 200, so the side yards are going to be 50 feet each. We also decided that in the center of the building, we would carve out a space that was 50 by 50 feet. So 1 inch would be 40 feet. I got to go to the half. And go back to the half. So we took out this as open space. We're not necessarily done. Then I decided that, then we determined that the minimum spacing of exits is going to be a third of whatever this diagonal is. So that's going to be the square root of 100 plus 200 squared. I'm going to do that on my calculator. $100 squared plus 200 squared. That's so the diagonal is 223. Let's just sketch it over here. This is 223 feet. So divide that by 3. The exits spacing have to be 75 feet apart. 74.5, right? Whatever. Let's just call it 75 feet. Let's say I want an exit, and then we said for stairwells, repeated several times in class, that it's reasonable to believe that we need stairwell dimensions to be 10 feet wide, right? Because we have a stair going 2 ways, and those stairs got to be 48 inches each. So a stairwell, 1 inch is 40 feet, so one of these would be 10 feet. And by 25 feet, so 10 feet that way, that's about the size of a stairwell. That would be 10 by 25. Right? So that's, we need 2 exits, right? Minimum 2 exits in the building, maybe 3 depending on occupancy, but let's just say that we're not going to exceed that. And then I decided on an exit here provisionally, because this is not a linear process. You don't always get it right the first time. And then one here, this corner of the building. Let's see what that spacing is. I'm just going to measure in inches and then multiply it by 40. So that looks to be about 3.5 inches. 3.5 by 40. That's my spacing so far. It's 140 feet is more than 75. That's going to be fine. And we have to connect these with a corridor, so that most direct path would be something like that. But maybe I want to take this space and divide it in half, right? Remember, the wings of this building are, if this is 50 feet, the building's 200, then I've got 75 on each side. So I might want to split that down the middle. So this might be the path connecting the 2 exits. Maybe I'll develop some kind of lobby here. Now, we did not take this to the next step, but one of the important things you'll know from your reading your means of egress reading, that the next step in analyzing your corridors is that you have to um, constrain your dead ends to the maximum allowed travel distance, and the dead ends, right, shall not exceed 20 feet for unsprinklered and 50 feet for sprinklered buildings. I mean, I can look it up in the code, but I'm pretty sure that's right. Dead ends, 20 feet for unsprinklered and 50 feet. So I can't travel in any direction that leads to a dead end that's longer than 50 feet. That means if my stairwell is here and my corridor were to continue in the building in this direction, that distance, because it is a dead end, cannot exceed 50 feet. Now, what else can we do? We could put the exit there, right? That may be an argument for moving the exit somewhere nearer, or the building could simply become shorter. Let me see what that implies. Take a piece of trace paper to this. So firstly, we do this with a slightly thicker marker. I think I have one here. Okay, here's the shape of my building. With the wings, right, the full size of that with the 40 feet. So I have one exit here. And if I leave the exit here, I can only travel in this direction 50 feet. So I'm proposing to move my exit here. Remember, the stairwell, 25 by 10 feet. So now my corridor can be this. Exit, exit, corridor. I haven't got the spine of it quite centered here, but the idea is that you would have program at the end of the corridor that leads to the stair, right? The exits have to discharge, by the way, to the public way. public way. So at first glance, this would work, and a two-story building of this height would work, as far as I can tell. Dead ends, and there's also maximum travel distance. And that is typically, it's different for sprinkler buildings. We'll have to look at the H Street drawings. I think it's 250 feet. So I can't be the most remote location in this building can't travel more than 250 feet. I don't think we're going to have a problem there. So this is one solution. Let's call this solution A, or provisional. Let's draw a different solution. Let's try a different solution. Take the building, and this time, oops, I'm going to keep the exits there. And I'm anticipating that I can't occupy the entire wing, because if I travel in this direction, I'll exceed 50 feet, and that would be a dead end. Very simple proposition here. Simply make the building L-shaped, right? And this is open space. And the corridor, if you want a double loaded corridor, there's exit. And this is solution B. We have a smaller building, right? We have 75 feet here, 200 feet. 200 minus 75 would be 125 there, and I think that's 50 feet that way. 100 feet on this side. So these are the two solutions that would work. If the footprint were 200 feet by 100 feet, right? Here we have a slightly irregular shape. Here we have a more symmetrical shape, but we needed to displace this exit so we avoid a dead end corridor here. Your drawings should have dimensions. Let's just finish up with the, right? And should indicate the scale. So I will look at individual drawings and see if they survive this means of egress consideration.